Hey, this will be your accumulating functions test solutions. So for number 1, we're given a graph of f, and it's always a good idea to note which graph you're looking at. And you're given here a definition for g. And so the very first part of A wants us to find g at 4. And we see that g at 4 is going to be equal to the integral from 0 to 4 of f at t dt. And so here, this part, just g at 4, that's really talking about the bounded area. That's important for us to remember. So we're going to find the area from 0 to 4. So we do need to find the bounded region inside here. And if we do 1/2 base times height there, we should end up with -1 for our bounded area, and negative because we are below the x-axis. And then we need to find from 1 all the way over to 4, so we need to find the area of this trapezoid here. And that's going to be 1/2 the height of the trapezoid, which we see is 2, times the sum of the bases. So 1, 2, 3 plus 1. So notice we're going to get 4 for that bounded region. And so the area here is going to be -1 plus 4, which is 3. Now g prime at 4, the next part, that's going to be equal to f at 4. So that part is going to be just the graph. We're looking for that value from the graph. And f at 4 we see is 0, so that means g prime at 4 is going to be 0. And then finally we're asked for g double prime at 4. So g double prime at 4 is equal to f prime at 4, and that's talking about the slope. So what is going to be the slope on the graph at 4? So we can very quickly do here, we've got our 2 points, and you're going to do your changing y's over changing x's. And so if we do that, we're going to have -2 minus 2 over 5 minus 3. And so we're going to end up with -2. So notice how each part has a specific place that it's talking about. All right, so now for part B, you want to know at x equals 1, does the graph of g, so keep in mind you're talking about g, have a relative min, max, or neither? So whenever we're talking about the g's graph, keep in mind for a relative min, max, or neither, that's going to be a critical point. And so we first need to see, well, at 1, we need to see, well, what's going on there at 1? So for this to be a relative min, first we have to note that g prime at 1 is going to have to be 0. Well, let's see if that's true. G prime at 1 is really equal to f at 1, and f at 1 is 0. So that is true. So for us to have a relative min or max, we have to have a sign change at 0. So notice that we do have a sign change in our graph. So we can say that g has a relative minimum at x equals 1 because, and we can say f at 1 or g prime at 1 equals 0, and f changes from, and notice that it is from, and we're looking at a positive to a negative, or a negative to a positive, in this case from negative to positive. And that's all the reasoning that you need to put there. Okay, for number 2, we are going to try to figure out what f at 3 minus f at 0 is. Well, I know the integral from 1 to 3 of f of x dx is 2.3. So that's telling me that from 1 to 3, so this bounded region all the way down here to 3, every bit of that is 2.3. Now keep in mind that that also implies this notation is telling me that f at 3 minus f at 1 is 2.3. So if we can compare that to this notation, this is actually talking about the integral from 0 to 3 of f at t dt, or f at x dx. And so this is wanting to include all of that area. So that part, this portion here, that's really talking about adding in this amount of area here. And so in order to do that, we find that bounded region is 2. So we're going to have 2 plus 2.3, and that's going to give us 4.3. Okay, so our next problem, we are looking at which interval will satisfy both these conditions. So our first condition, if dy dx is greater than 0, then I know that f is increasing. So let's look at some of our answer choices. From a to b, we see our function is increasing, so that's okay. From b to c, we are still increasing. However, from C to D, we are not increasing, so that means answer choice, or Roman numeral 3 is out, and so is answer choice C and E. So it looks like we're going to have to test 1 and 2 to see. So now let's go to our next part. We're talking about our second derivative. So the second derivative is going to talk about concavity, and since the second derivative is negative, f is concave down, like a frown. So of these remaining two, we need to see, well, where would I be concave down? Well, this portion here, that's going to be concave up. This portion here, that's going to be concave down. So the only interval that we have where we are going both increasing and concave down is going to be number 2 from B to C. So the only answer choice should be B. The next problem, we need to order all of these. So let's look at what's going on with h at x. Notice how h at x is defined. So very quickly we can go through and say, well, I know h at x, that's going to talk about our area. And then h prime at x, that's going to be our graph. And then h double prime at x, that's going to be the slopes of our graph. So we can see real quick how to apply. So let's go through and talk about h at 6. Well, h at 6 is going to be that bounded area. And notice this bounded region, all of that is below the x-axis. So I know all of that is going to be negative. So h at 6 has got to be less than 0. Then let's look at h prime at 6. Well, h prime at 6 is equal to f at 6. And f at 6 we see there is going to be 0. And then finally, if we look at h double prime of 6, which is f prime at 6, or it is positive here, or it's talking about the slopes, notice that this graph is increasing there, so that slope is positive. So we need the ordering from negative, and so to 0 to positive. And so first thing we see the negative value, so C, D, and E are out. And then from a negative to 0 to positive. So that's going to give me answer choice A. Okay, for our next problem, this is a good review of PVA. And let's go quickly through that. PVA, position, velocity, acceleration. As we're moving down this chain, that is your derivative. which is also going to talk about slopes, concavity, increasing, decreasing. Now moving up this chain, that is going to be your antiderivative, and the biggest application that we've looked at so far of the antiderivative is area. So here we're going to be applying our antiderivative because we are given a velocity graph and we're asked distance, or that's the same idea as position, from time t equals 0. So what we need to do to find that is we need to find the bounded area under the graph. So all of this, if we can estimate this area, then we know the distance traveled. So if we look at just one box under this curve, we see that one box represents 10. And so if we go through counting up, let's see how many 10s we would have here. So there very quickly we have 1, 2, 3, 4, 5. And then we'd have 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, almost 19. So that's 190. But then we also still have this portion we've not counted. And then we have this little portion. And so if we continue on looking at just these little bitty portions, then we see that that best estimate is probably going to be 210. Okay, for our next question, we need to find the values of g at 2 and g at negative 2. And we need to note that g of x is defined as that bounded area. So a good side note, now definitely don't write this on your test papers, but this is just asking for that bounded area. So when we go to set this up, keep in mind that that bottom number is not 0, but you are starting at 1, and that is a place that some people messed up on. So we're going to have g at 2 equals the integral from 1 to 2 of f at t dt. And so that's talking about our bounded area. And so if we go from 1 to 2, then we are looking at this small region here. And so we can you can go through and try to develop where this other point value comes from, or you can do a fairly educated guess. You know down here is going to be -1. And so up here was 0. So it kind of looks like right through here, that's a safe bet that that is -1/2. And so your area is going to be 1/2, your base, which is 1/2, times your height, which is 1. And so that's going to give us 1/4, but then we need to keep in mind that we are below the x-axis, so that's going to be -1/4. Now let's go ahead and find g at -2. And so right away we see that our endpoints are going to have to be flipped. So I'm going to go ahead and incorporate that. F at t dt. And that's going to be equal to, and again, keep in mind you're looking for bounded area. So we will go all the way back to -2. So we're going to find here, we have this region. And if we find the area of that triangle, over here to the side, we're going to do 1/2 the base times the height, which looks like it's going to be 3. And so that's going to give me 3/2 for that area. But now keep in mind, we are going all the way over to 1, so we need to also incorporate the area of this semicircle. And so if we go over here to the side and find that area there, and I'm going to put that up there, that area is pi r squared. Well, my radius here is going to be 1. And so here we are going to have all of that. So that's going to end up giving me pi, but keep in mind this is a semicircle, so I have to divide that by 2. So that's going to be my bounded area. And it's going to be a -pi/2 because you are below the x-axis. So let's go ahead and put all that together. So we do have this negative, don't forget that. and then we had 3/2, and then the negative pi over 2. And you're welcome to leave it like that, or we could put negative 3/2 plus pi over 2. Either would be fine. All right, so for our next part, though, we now need to find g prime at negative 3 and g double prime at negative 3. And so this is going back and remembering how g of x is defined. And so g prime at negative 3 is going to be equal to f at negative 3. And keep in mind, that's going to be just the graph. So f at negative 3, we're going to go back over and try to find that value. So negative 3 is going to be in this region here. And we can count off our slopes and find that we're going to end up here. We have somewhere between 3 and 1, and if we look and do our slopes, we would see that's going to give us a 2 there. So g prime at negative 3 is going to be positive 2. Now if we do g double prime at negative 3, that's talking about f prime at negative 3, and then that, keep in mind, again, is talking about your slopes. So the slope of that line, use your 2 points that you have and do your slope formula. And so that's going to be 1 minus 3 over negative 4 minus a negative 2. And so notice here we're going to have negative 2 over negative 2 or positive 1. All right, so for our next question, and this one really tripped up some folks, so let's be careful with it. It talks about for the x coordinates of each point that the graph of G, not the graph of F, but the graph of G has a horizontal tangent line. So I would stop there. If the graph of G has a horizontal tangent line, that tells me that G prime of x is going to be equal to 0. Well, how does that relate to what I'm given? Well, look at how G is defined. So that would in turn, if G prime is 0, then that would also mean that f of x is 0. And for each of these particular points, we need to determine if we have a relative minimum, a relative maximum, or neither. So let's look at our graph and see. We're going to have f of x, or that graph, is going to be 0 at negative 1, and it's going to be at positive 1. Now at negative 1, this area here, G is going to has a relative, and that's going to be max, because f changes from negative to positive. Or I'm sorry, positive to negative. I said that backwards. All right, so then at x equals 1, we have neither. G has neither. And that is because f does not change signs. All right, so there's that, and be careful again how that's relating. And then the last thing here that we are asked about whether or not we have a point of inflection. So let's again go all the way back and think about what it implies for us to have a point of inflection. That's going to occur when G double prime equals 0. And I know G double prime is equal to F prime. And then here, again, if we're talking about that point of inflection, we also have to have a sign change. So we can think of this as F prime is going to be the slopes of the graph. So slopes are changing. But we can also even go even farther back. If the slopes are changing, then that would imply that F is changing from increasing to decreasing. Of changes from increasing to decreasing, or the other way around, either one. Now, where does that happen? Over what intervals is that going to happen, or at what x value, sorry, they didn't want the intervals. So where do we change from increasing to decreasing, or decreasing to increasing? That happens when x equals -2, when x equals 0, or x equals 1.